Okay, we've got two events A and B, and we're given that the probability of B is 0.8, the probability of A given B is 0.25, and the probability of B given A is 0.8. We're asked to find a few probabilities, including the probability of A. So let's start off with the Venn diagram. So we've got set A, event A and event B, and we'll put the information on that we know. So first of all, probability of B is 0.8. We'll put that straight in here, 0.8, which means that this region plus this region, all of B, is equal to 0.8. We've also got the probability of A given B is equal to 0.25. So given that B occurs, we're saying the probability of A, which would be this part in here, is 0.25 or 1/4. So we want this part here to be 1/4 of all of 0.8. So it must be 0.2. 0.2 over 0.8 gives this 0.25 or 1/4. So straight away we know this intersection between A and B is 0.2. That means we also know that this region here is 0.6, 0.2 plus 0.6 is 0.8. Okay, next thing to complete our Venn diagram is we've got the probability of B given that A occurs is 0.8. So in other words, the probability of B occurring given that all of A occurs, probability of B 0.2 here, comes out to 0.8. So we can use a bit of algebra, and using the fact that we're trying to find the probability of A, which is this whole region here, we might call this part here X. So then we can use a bit of algebra here and this probability. So we know that probability of B given A is equal to 0.8. In other words, probability of B, now because the condition in this case is A occurring, B is now restricted only to 0.2. So we can say that 0.2 over the new condition, which we've used X, is equal to 0.8. From there, a bit of basic algebra to solve this equation. We end up here with X is equal to 0.2 over 0.8. And we can see here that, just moving up a little bit, we get a value here of X is equal to 0.25. Okay. So if all of X here is 0.25, it means that this little region here must be 0.05. And then also we can work out the region outside the circles here because of the probability in the universal set must add to 1. We get 0.25, 0.85, this must be 0.15. Okay, so that allows us to work out some of the probabilities. So probability of A occurring, already figured that out, that's 0.25, that's easy. Probability of A union B is everything in A and B inclusive, so it's each of these three regions added together, which would be 0.25, 0.85. Probability of A union B complement, everything outside of A union B, which would be the 0.15. And then the final one to have a look at is this one here. Probability of A intersection B given A union B. So in this case here, the condition we're saying is A union B must occur. That's our condition. So that goes on the bottom of our fraction. A union B is 0.85. And A intersection B is 0.2. It goes on the top of our fraction. So there's a solution for this probability, and probably a good idea to simplify that. We might change that into 20 over 85, and then simplifying by dividing top and bottom by 5, we get 4 out of 17 as a fraction.